Hi everyone, my name is Suchit and I will be showing you the implementation of Kalman Implementation principles under the guidance of Professor Chenchu. My project partner is Rohita Tejaswi Putluri. We'll start by opening Qsys and creating a new project. So as soon as the quarters window opens, you can get an option to create a new project. You can just go select that, press next, make sure you select the file in which you want your file to be created and generated. In this case, it is final. And my name is Kalman Print. So if we don't have any log files, we can just go ahead and select the device type family and go for the pen count for the fastest process. We can just go B2C2484C7. Next, we're using Verilog coding and we're using multi-monitor for simulation, so that'll be fine. Just finish it. As that's finished, just go to, there's no problem, so just go to Qsys. Qsys is the tool in which you can just drag and drop putting the modules to create a system. It's going to take some time to create new results. Now that's done, we'll be using Windows 2. And we'll be using economical version. Finish. Uncheck memory. RAM. That's good. Using performance counter. Clock and reset for all the modules. Now we'll use the instruction master to connect to the uncheck memory and the data master to connect to all. Now we'll connect the clock and reset, the JTAG debug monitor reset, and finally we'll connect the interrupt requests so that the interrupts are handled, and that should be it. So we have theoretically 8 addresses down here, which can be reduced to 2 by assigning base addresses. Now once we have assigned the base addresses, we can just go and check Qsys, and we can assign vector memory to unchip, and then you go for unchip memory and you can increase the size to 8192, bigger the better. So we're still getting 4 errors. Let's see what they are. Right, so once we assign base addresses, everything's done. Now what we need to do is save the file, make sure the name is same as your project. Yeah, so that's the one. As it's saved, you can just go and generate the file. It's going to take a couple of minutes to generate a QIB file, which is a script containing Verilog files for all the modules that you've added. So you can only add the QIB file and you can get the project done. It's going to take a couple of minutes. It's compiled pretty successfully, so it's fine. You can just check if everything is hunky dory here. So use Qsys, Yep. So now, if everything is fine, you can just close this. Then we need to add the QIP file into the project. To do that, by selecting files and adding, just selecting the required file. So just edit final, we are in QIP file present here. That's the one. Adding it. These are extras, so this is the one which I'm adding. Apply. Okay. That's it. As long as that's done, the next step would be to assign pins to sync_shk, because that's the name given in the QRP file. And you have to assign location. You have to assign IO standards, and you have to assign locations. That code for the pin device. You can use IO standard as 3.3 MTTL. When that's done, just save it and run it. It's going to take quite some time to run, so if you're used to. Yeah, and when you're opening Neos 2, please make sure that the workspace is pointing to current project. Just browse for that. And you can create a new folder in it. That's nice. Yep, that's the new folder. Let's create your workspace for the Eclipse. Now when this opens, you just check if the compilation is done. It's going to take quite some time. Looks like it's still taking some time. Just make sure that you're not getting too many errors out here. In the meanwhile, we can just keep this open. So keep the pages of the virtual ones, and then we're going to burn this code onto our file. Just make sure that these master is set up and recognized. Now we're going to add an SOF file. Device, and the device is recognized. Pretty good. So just go start, and your code is pushed into your FPGA. So when that's done, you just save it. On the output files, I think you will be fine. So I would say just when that's done, and when your compilation is all done, so you can just go and create a new user application basically from template, and make sure you get the right path here. The same thing. Make sure the that the project name is taken correctly. It is not yet final. Open Kalman Implementation info. Excuse me. So as long as that's done, you can just go and give a project name for this. It looks good. Just make sure that it's going into the same folder. You won't have any issues. And we'll be using a Hello World Small. It's taking quite a bit of time, but I think it should be done. So here we go, it's Hello World Small, and this is the C code for Hello World Small. If you notice that the paint is properly finished, and once you can check this out, the Hello from NEOS2. Now when you run it on the NEOS2 hardware, you're going to get this code pushed to the hardware, and then comes back, and then it's going to confirm by showing the NEOS2 console here that I've shown you right here. So we'll just build the project. Now the reason why we're building this project, even though we don't have any relation to it, is because we can use our code in place of Hello World through the project. All we use the Hello World is for just checking if the device is connected properly to the system. So let's just see if it is connected right. Great, so if it's building fine, then we can just go and run as next to local hardware. Now they should create a window using the SD console. Right, so that's what we're waiting for. Yep, so that's fine. That means everything is connected properly. So it's going fine. Now what we do is we take our code, copy it, and then replace the code present here. So everything's fine. Just make sure that you save the file. And then you build the project again, just to make sure that you don't have any errors going on. Great, so since there are no errors, you can just go ahead and run as news to hardware. And that's how the code is getting run. So we can see that we got 2861054 cycles from the Kalman filter software. Um, and that's how you can run a software code on your processor. For the hardware code, we were not able to implement it properly because it already find values in between. Um, that's it.